Okay, the graph below shows the change in temperature when an ice cube is left on a kitchen table. Which part of the graph shows a change in state from solid to liquid? Now, what do we already know? We already know several things. We know that solid needs to absorb heat in order to melt into to become a liquid, right? Melt to become a liquid. Okay, so this is strong here. In order to melt to become a liquid. Okay. Now, uh, so that means there must be a source of heat. Now, in this case, the source of heat, because the question states that it is left on a kitchen table, so the source of heat must be the surrounding air. Okay, so maybe we just note that down. Source of heat in this case is the surrounding air, the warmer surrounding air. Okay, right? So the ice is absorbing the heat from the warmer surrounding air. Alright, so we also know that ice melts at 0 degrees Celsius to become water. Alright, so at 0 degrees, this is 0 degrees Celsius. So at 0 degrees Celsius, ice melt become water. Alright, we also know that water boils at 100 degrees Celsius to become water vapor. We also know that liquid water could never be above 100 degrees Celsius. But because, this is very important, because the source of heat in this question is only the warmer surrounding air, it could never reach 100 degrees Celsius. Why? Because the temperature of the surrounding air is only between 25 to 30 degrees. So let's put it at its maximum, 30 degrees Celsius. Okay? Alright. Okay, so ice melts at 0 degrees Celsius. Room temperature is about 30 degrees Celsius. Now, we also know that ice is absorbing heat. We know that heat travels from an area of higher temperature to an area of lower temperature. Okay, we know this. We know that heat travels from an area of higher temperature to an area of lower temperature. But we also know that heat, this happens, okay, this continues, this transfer continues until the temperature becomes equal. Temperatures become equal. Okay, so what this means is that if I have ice and the ice is at 0 degrees, it will absorb heat from the surrounding air, which is at 30 degrees. So warmer 30 degrees, heat will be transferred to the colder 0 degrees. And once it reaches, once enough heat is absorbed into the ice until the ice becomes 30 degrees Celsius, until the water becomes 30 degrees Celsius. So the water will be at 30 degrees Celsius, surrounding air will be at 30 degrees Celsius. Alright, both the temperature becomes equal, then there will be no more heat transfer. Okay, so knowing all this, we can then try to answer the question. Which part of the graph shows a change in state from solid to liquid? The answer is between E and F. Okay, so while it is melting, ice remains at 0 degrees. Water that has just the water that has just been melted from the ice also remains at 0 degrees Celsius until the ice has completely melted. Then the temperature starts to increase. So from F to G, there's no more melting. F to G, it is already in liquid state. Okay. Now what happens then to G and H? G and H is, oh, sorry, G and H is again G and H, the water or the liquid was already at room temperature, and which means it is already at the same temperature as the surrounding air, and no heat is therefore gained anymore, and there is no loss or no heat transferred from the surrounding air to the water. Okay, so because both are already at 30 degrees Celsius, they remain the same. Okay, so I hope you understand this question is a very common question. Please take your time to listen to this video again and again if you don't understand it the first time round. Okay, that's the good thing about videos. You can always replay, pause, and replay, and so on. Okay, thank you.